Okay, welcome to my new video. Now I'm going to show you the Nand Gate. The Nand Gate is a fundamental digital electronic logic gate that is commonly used, and here you on the left side you have the digital uh, logic symbol schematic. So this is how we draw the NAND gates on electronic circuits. Here now you will see that this is the truth table. Its output is always going to be 1 except if all the inputs or both in this particular example are all on 1. So it is kind of like an AND gate with an inverter on the output. Okay, as you can see, here is the description of it. It combines the NOT function with an AND gate. Output only goes low when both inputs are high. So if you watch my AND gate tutorial video, you know that the AND gate is always gonna have 0 if just one input is 0. But the NAND gate acts opposite of the AND gates. So let me go here to my Proteus and we're gonna run the program. So here now when I run the program, you will see here on the output it is always gonna be 1. So when I just put 1 here, it doesn't change. If I put 1 on the B input, it also doesn't change the output. But if both inputs are on 1, then the output is going to go to 0. So yeah, this is the basic principle with both two inputs. Here we have I forgot to put here on switch a text on the switch A and switch B. So when it is closed, this switch acts as 1. If it's opened, this switch acts as 0. Let me just stop the program for a second. Just quick example. So if just one switch is open here, there won't be current going through this middle side of the electronic circuit, but so all the current will go through the lamp. But if both switches are closed, then the current will go and there won't be a lot of amount of current going through the lamp. So let me just run the program. So if one switch is opened and closed, there's nothing. But if both switches are on the low input, as you can see, the lamp is still glowing a little bit, but not bright as when I open the switch. So this is like a NAND gate. I forgot to put a resistor here. So when I open just one switch, the output is going to be on high 12 volts. But if both switches are on on 1, then the output is going to have a small amount of current here, so it goes less brighter than when these circuits are opened. So now here I'm gonna show you the transistor logic. Okay, only if both inputs are 0, like so, I just put 0 here and 0 here. These two transistors Q1 and Q2 are gonna be blocked. So if it is here blocked, then here also is 0 voltage. There won't be current goes the transistor into the base Q3. So this transistor here is also blocked. So then the output here is going to be 5 volts because there is no current drawn through transistor Q3. Now when I run the program, remember these both inputs here, A and B, are on low, so that the output is going to be on a high state. But when both inputs are on 5 volts, which acts as 1, and now you will see that both transistors here conduct current, and here we have a current that goes through the base to the base of the transistor Q3. So this acts here as a NOT gate. Here we have a high voltage, and here then we're gonna have a small amount of voltage that isn't enough to be 1, it is just a 0 state. Okay, I just showed you this digital schematic, I just showed you the switch analogy, and I just showed you the transistor analogy. Now I just want to tell you that if only one input is 0, the output is always going to be 1. Here is an example. I'll do all the combinations, and you will see that it is always going to be 1 on the output. But if all inputs are 1, then the output is going to be 0. Also, if you have 4 inputs, if you have 5 inputs, it only changes to 0 if all the inputs are on 1. Here we have, I don't know, 8. I'll just make it like that. Now you will see, yeah, and here it's now 0. Here we have 12. I'm gonna just put all on 1, and it's gonna be 0 if only all the inputs are on high state. We have here 13, and you can do this for even thousands of inputs. The output in the NAND gate is gonna be 0 only and only if all the inputs are on a high state. Okay, so that's it for the NAND gate. I hope it helped you, and see you in my next video where I'm going to do an OR gate. Thank you, and see you next time.